Assalamu alaikum wa rahmatullah. In this video I will show you how to take data for experiment 1, power flow and voltage regulation for lab 1. I'll show you how to take the data as in this table for resistive, capacitive, inductive load and open circuit and short circuit, how to create data table from the metering. So we'll go to the system. This is what we did last time, the connection. Now it is connected to resistive load. Everything is ready. We just need to switch on the data acquisition first and we switch on the source. We'll go to metering first. Metering. Now all meters can be programmed. So we better to start with E1 as we have in our table in the experiment. We have E1, B1, Q1 and then E2, B2, Q2. So it's better to keep this order. Now what we need to do, this is E1, so we can program this one to be I1. Of course we don't need I1, but we need it for measurement. And then we go to power, three-phase power, that is B1, and we need also to see Q1, so also power, three-phase power. This will be B1 and this will be Q1. Now for this one we can program it to be E2 voltage, E2, and this one is I2. This one we can program it for B2, and this one for Q2. So power, that is E2 I2. This will be B2 and this will be Q2. We press this one for continuous refresh and then we go to our connection. We start the system. The voltage is on, transmission line is on, resistive load is on 1200. So we'll just go to, we can see we have the voltage sending and receiving current. We have B for sending and B for receiving. Since we have resistive load, Q is almost 0, and we have Q, that is the losses in transmission line. Now if we go to create a table, data table, so create, record setting, we need E1, B1 and Q1. We don't need the current. We also need E2, B2 and Q2. This all what we need. We don't need the rest. So apply, yes, and then you can rewrite this. So this is B1 and this one is Q1. This is E2, B2 and Q2. Now if you want to keep the order for the readings as in the experiment, we have open circuit, then inductive, then resistive and so on. If you want to keep this order, so then the third row is the resistive. As we start with the resistive, we just go to the third row, this one. We keep the cursor there. Now we go to the experiment. Now it is on. Everything is on. We just need to take the data. So we said record. Now all readings are recorded. Then we go to inductor. Inductor, that will be row 2, for example, inductive load. Now to do that we need to switch off the source, switch off the data acquisition, and then just shift these wires to inductive. Very simple procedure. Then again switch on the data acquisition, switch on the switch, go to data table and then press record. That will be your record or your data for inductive load. Then the fourth one is capacitive load. As we agree, the first one is open circuit, the last one is short circuit. So this is capacitive load. Now we just go again there, switch off the system, shift those wires to capacitive load, and from part 1 the video we choose the load to be 1200 for 3-phase, 1200. So we just switch on. You can see that we already have data there, and you can see that Q is in negative now, and the receiving voltage is very high as we have capacitive load. So we go to data table and we say record. So this is the record for the capacitive load. Okay, now we need with open circuit and then short circuit. So we start with open circuit. We see how to do open circuit. Switch off the system. So for open circuit we disconnect the load, delete this wire and these 2 wires. For open circuit we just need to measure the voltage between this point and this point, nothing else. Everything should be open. We just need to measure the voltage because the current will be 0. So switch on the system. It is on. Go to data table and say record. It will record for open circuit. You can see that voltage is the same, but the current will be 0, so that B2 and B3 will be 0. This is the same readings as in the table. This is the meter. The last part is for short circuit. We just disconnect again. For short circuit, instead of voltmeter we need to connect an ammeter between two faces, ammeter, but also we need to short the third one to this point, the second point of the ammeter. We need to short circuit the third one to it. Okay, so we have ammeter, voltage will be 0. Okay, let's switch on the power supply, go to metering. So you can see the voltage E2 equals 0, very high current. Okay, we also of course don't have B and Q because it is short circuit, but we have B and Q in transmission line. Let's go to data table. So this one is the short circuit test. See, now according to the experiment we have all data we need: open circuit, inductive, capacitive, resistive, capacitive, and short circuit data. We can now measure from the figure, we can measure the losses in transmission line, and we can find out the simulation. So these are the data. What we can do after stopping the system, so system we can just hold it. Then this data table, this data we can just copy and paste them in Excel or Word file, and then find out the measurement we need for the losses and for voltage regulation. Thank you very much. Stay safe, stay home.